Alright, so let us carry on and look at the volumes or by washer method. Right, so this is the volume. Okay, look at the volumes by the washer method now. Okay, so remember previously we talked about the disk method, but right now we're gonna be looking at the washer method. Okay, so looking at the washer method, it is pretty simple. Right, so if you have a washer method, remember that your washer is something like this, right, with the hole. Okay, this is hollow, so I'm just gonna do it like this. Okay, it's like a donut, right? So we have something like this. Okay, so on a washer, if you have a center right here, you will have your inner radius, which is a small letter R, and your outer radius, which is a capital letter R. It's the same procedure. Look at this. The line at the top, right? We have a line at the top and we have a line at the bottom. So it's the same thing. We say top minus the bottom. Okay. But now, what is the top line? The top line is just a radius from the center, which is capital letter R, so it should be capital letter R minus a small letter R. So let's just bring this up to an example. So consider something like this. Is a pretty common example, right? So we've got the curve right of here, the first curve, which is going to be our g at x, and then we have another curve right here, which is your y is equal to f at x, right? So you have something like this. Now when you revolve this about the x-axis, okay, so you will have something like this. I'm going to try to be professional, right, something like that. And then, okay, I don't know whether you can see that or not, but try my best. Okay, so you will have something like this. Okay, so you see right now that right over here we have a hole. That is a hole right here. We have a hole, right? So it is hollow. So now, what is the volume of this? Remember that we said it's going to be a capital letter R minus small letter r. So the volume is going to be equal to an integral. Since we revolve this about the x-axis, so that's going to be from A to B, right? We're still looking at pi because that is a circle, right? That is a circle. But now we've got two circles, okay? So which means right over here, we have to see that it's the same thing from the error part, where we say the top minus the bottom. So the top curve is going to be your f at x squared, right, minus your g at x squared, and then dx. So this resembles the one that I love, because right here I made an example with f at x, g at x. Yeah, that's going to be your curves, right? But now, to be on a good track, right, you're going to be using the radius. So it's going to be pi, and then in this case it's going to be r, the capital letter R at x squared, right, minus the small letter r at x squared. This is going to be a dx. This is what you will have, okay? So that is the formula you're going to be using for the volume using the washer method. Right, so let's look at the example. Right, so this is example number 1. Right, so example number 1 right here we have f at x, which is going to be equal to 1 over 2 plus x squared, right? And then we will have g at x is going to be equal to x, okay? So it's pretty much the same thing as that one at the top, right? Because when we sketch this, you will see that it's going to be like, okay, this is just your y is equal to x, so it's going to be something like this, right? So you be like that, okay? And then you will have this x squared, but now it has been shifted half unit up, so it's going to be like this, okay? So you have this, right? So when you revolve this about the x-axis, you will have something like this, right? And then that is going to be your volume, right? So finding the volume of this is not drawn to scale. These diagrams are usually funny, right? But I want you to get the idea. Okay, so right over here, you're going to say that the volume is going to be equal to integral, okay, from A to B. Now, since right over here, we're not giving A to B, we are given, okay, So I just forgot to add that this is from 0 to 2, but if you're not given, you're just gonna have to equate that and then try to find the point of intersection, right? So in that case, it's gonna be from 0 to 2, right, of the top part. What is the top part? It's gonna be that. But now look at this. When you start from this point, you go all the way up. Okay, so the top curve is the big R. Okay, so we're gonna have these big R at x squared. Okay, minus this small r right over here, this one. Okay, so there's gonna be a small letter r squared. There's gonna be a dx. Okay, this is what you're gonna be having. Now remember that what is your radius in this case, right? Your radius is just gonna be a curve, right? So we're just gonna put the curve right over here. So from 0 to 2, what is our curve? The curve for the f at x is gonna be equal to 1 over 2 plus x squared minus, and then what is this one? It is just gonna be your x squared, right? And then dx. So right over here we have to expand this. So if we expand this 0 to 2, I guess it's gonna be what? It's gonna be 1 over 4 plus x squared, right? Yes, plus x squared and then plus x to the power 4. Still this is in parentheses, but let's just put that in parentheses, minus this, which is x squared, and then that is going to be your dx. Okay, and then let us carry on. So in that part we see right now that this will cancel out that, right? And then we're going to be left with the volume, which is going to be equal to integral from 0 to 2, right, of 1 over 4 plus x to the power 4, right? And then there's going to be dx. Now the rest is history, because right over here this will be a 1 over 4 x and then plus x to the power 5 divided by 5 integrated from 0 to 2, and then you're going to have to find your volume. Okay, this is how you do this problem. Okay, so yeah, that is how you do it. And then now when you revolve this about the y-axis, right, revolve this about the y-axis, it's the same procedure, but right over here is going to be added to y and added y, and then that's going to be your dy. Okay, so I'm just going to squeeze it right over here so that you will see it. Right, so formula for that, when you revolve it about the y-axis, right, axis, so this would be the volume. It's going to be equal to from c to d, right, of a pi, and then that's going to be your f at y squared minus your g at y squared dy. So it's going to be equal to, there's going to be your what, c to d of a pi, and then r at y squared minus your r at y squared dy. This is what you're going to have. Okay, so for the volumes of the wash. Alright, cheers.